Welcome to True Projects. In this video, we are going to explain about the project, which is PETchain, a blockchain-based privacy-enhancing technology. Introduction of the project. The project Privacy Enhancing Technology focuses on addressing the security and control issues surrounding the storage of sensitive user data by online service providers. Existing privacy-enhancing algorithms such as homomorphic and anonymity have limitations in providing comprehensive data control and accountability. In traditional online services, users are required to sign up and entrust their personal data to service providers, raising concerns about data misuse and lack of control. Centralized data storage poses a significant problem. Service interruptions occur when the central server is down, disrupting user access. So this project addresses these issues using blockchain for secure, immutable data storage, giving user control and employing AES encryption and IPFS for file storage. Blockchain technology is a decentralized and distributed nature, as well as its core features such as data encryption, immutability and verification algorithms explain how these features contribute to enhanced data security. There are many types of blockchains such as Ethereum, Bitcoin, Stellar, Ripple, etc. Each has its unique features, governance models, and target use cases. We are using Ethereum in this project. Ethereum goes beyond just recording transactions. It allows developers to create small computer programs called smart contracts. These smart contracts, without the need for a centralized authority, a legal framework manages tasks like storing and getting evidence data. Ethereum's strengths include its ability to create various decentralized applications and its active community of developers. Objective of the project. The primary aim of the project is to enhance user data security and control when utilizing online services, particularly in scenarios where sensitive information is involved. Blockchain is integrated into this project to ensure data immutability, distributed data storage, and enable smart contracts for managing data access permissions and interactions between users and service providers. AES, which is Advanced Encryption Standard, it is a cryptographic technique used to secure user data before storage. AES encryption is employed in this project to safeguard user data, ensuring that even if it is accessed, it remains unreadable without the appropriate decryption key, enhancing overall data privacy. IPFS. It is utilized for storing user data files in distributed and secure manner. IPFS provides resilient file storage system where data is distributed across a network of nodes, ensuring availability even if some nodes are offline. Requirements of the project. Hardware requirements and software requirements are needed for the project to implement. The first one is processor of i5 and above in hardware requirements, RAM of 8 GB and above, ROM of 25 GB and above. Coming to software requirements, Node.js, Python of 3.7.0 version, and Visual Studio Community version. To implement this project, we have designed various modules in the methodology. The first one is New User Sign Up. Here, either subscribers or service providers can register for the PETchain application, creating an account with their details. Login as subscriber. Here, subscribers log into their accounts using their username, password, and graphical image for enhanced security. Upload and share your details. Subscribers can upload their data securely, which is encrypted using AES encryption, and choose whether to allow or disallow service providers to access this data. The data is then stored on the blockchain, and IPFS and access permissions are managed via smart contracts. View log. Subscribers can view a log that shows details of all access to their shared data, including which service providers accessed it and when. View your data. Subscribers can access and view all the data that they have uploaded, including its sharing status. Login as service provider. Service providers can log into their accounts using their credentials, typically a username and the password, to access PETchain application. Access shared data. Service providers can view a list of data shared by subscribers, and if permission is granted by the subscriber, then they can download and access the shared data. This access is managed through smart contracts and the blockchain to ensure data security and accountability. Blockchain integration. User data is stored on the blockchain, which is a distributed ledger that exists across multiple nodes in the network. This distributed storage ensures data redundancy and availability even if some nodes go offline. Blockchain facilitates the execution of smart contracts In the project, smart contracts are used to manage data access permissions and interactions between users and service providers. These contracts automate the process of granting or denying access to data, enhancing security and control. The project uses blockchain to store references to user data stored on the interplanetary file system. This ensures that users can reliably retrieve their data by referring it to address on the blockchain. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the PETchain folder. It consists of Python code files that are intended to be dynamically loaded into project code during runtime. This is PETchain app folder. It comprises of a static folder, templates folder and Python code files. Coming to static folder, it contains files related to CSS, JavaScript and Bootstrap files. These files contribute to the visual and interactive aspects of the application. Coming to templates folder, this folder contains all HTML pages used throughout the project. It includes pages like index.html and more, representing various sections of the website. Coming to Python code files that will be executed during the runtime of the application supporting its functionality. This is the manage.py file. It is a command line utility that comes with the Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations, and more. This is the PETchain file. This file consists of a Solidity code. It handles data structures, functions, and events with modifiers for validation. Now we have to open HelloEth folder. This is the node module folder. It contains dependencies or modules needed for our project. Now we have to open it. This is the bin folder. It contains executable scripts related to project dependencies. Now we have to open it. This is the run blockchain.bat file, which is Windows batch script to start the blockchain. This script will initiate the local Ethereum blockchain for development purpose. Now we have to double click on it to start the blockchain. Blockchain will be hosted on the local machine at the address, which is the localhost and the port. This address allows us to interact with the blockchain using various tools and applications. So here we need to execute command which is truffle space migrate. And now we need to click on enter. This will compile and deploy smart contract. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. After running the migration, we will receive a unique contract address. This is the unique contract address. This address represents the location of our deployed smart contract on the blockchain. And here we have gas used. To execute the Solidity file and compile smart contracts, this is the amount of gas used. Now we will minimize it and return back to the main directory. Now we have to double click on start ipfs.bat file to start the IPFS server. So I'm double clicking on it. IPFS server is started. Let this be running. Now we will minimize it. Now we need to double click on run server.bat file. So the Django framework will host the application locally at the default address, which is localhost and the port. Now we need to copy this local link provided by the framework and paste it in any browser. Now I'm copying it. In Google Chrome, we'll paste the link. At the end, we need to type index.html and click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Django framework. Here in the home page, we have various links which are service provider login, subscriber login and new user sign up here link. So first we need to click on this new user sign up here link to sign up as service provider and the subscriber. So I'm clicking on this link. Here we need to enter all the sign up details of the service provider and the subscriber. So first we will enter details of the service provider. Here we need to give the username, password, contact number, email address, address of service provider, and in user type we need to select as service provider. And now I need to click on choose file to upload graphical password for the service provider. So I'm clicking on this link. So I'm selecting this as the graphical password for the service provider, and now I need to click on open. And now I have to click on submit. We can see that sign-up process of the service provider is completed and records are saved in the blockchain. This is the blockchain identity address of the service provider. Now we will give all the details of subscriber. So here we need to enter username of subscriber. Here we need to give the password. And here we need to give the contact number, email ID, we need to give the address, and in user type we need to select as subscriber, and now we need to click on choose file to upload graphical password for the subscriber. So I'm selecting this image as the graphical password for the subscriber. So now I need to click on open, and now we'll click on submit. We can see that sign up process is completed and records are saved in the blockchain, and here we can see blockchain identity address of the subscriber. Now we'll log in as subscriber. For that we need to click on subscriber login link. Here we need to provide credentials of the subscriber. So here we'll give the username, password, and now I need to click on choose file to upload graphical password. As I selected this image in the sign up time as the graphical password for the subscriber, so we need to upload this image to get the access. Now we need to click on open, and now we need to click on login. So here we can see that subscriber has logged in successfully, and here we can see various links which are upload and share your data, view log, view your data, and log out. So first we need to click on upload and share your data to upload the data. We need to enter data description and then select data sharing type and then upload the data. So first we'll give the data description. And in sharing type I'm selecting as allowed, and now I need to click on choose file to upload the data. So I'll select this file, and now I'll click on open, and now I'll click on upload. We can see that encrypted data hash code is saved in the blockchain, and data saved in IPFS with the hash code. This is the hash code, and chosen data sharing type is allowed. In this way we can also upload other files. So first we'll give the data description. And in data sharing option I'll select as not allowed. If we select not allowed option, blockchain will not allow service provider to view or access to this data. And now we need to click on choose file to upload the data. So I'm selecting this file, and now I need to click on open, and now we will click on upload. We can see that encrypted data hash code is saved in the blockchain, and data saved with IPFS with hash code. This is the hash code, and here we can see chosen data sharing type is not allowed. And now we need to click on view log link to view details of all users who has access to our files. Here we can see that no service provider has access to our files, so here we can see no details. Now we need to click on view your data link to view all files uploaded by the subscriber. So I'm clicking on this view your data. Here we can see subscriber name, data description, sharing type, file name, upload date and time, blockchain identity address, and link for download and view data. So now I'll click on click here link for degree certificate data so that I can download the data in decrypted format. So I'm clicking on click here link. In the status bar we can see that the data has been downloaded in the decrypted format. Now we will log out and log in as service provider to access the files. So I'm logging out. Now I'm clicking on service provider login. Here we need to enter all the credentials of the service provider, which are the username, password, and graphical password. As I selected this image as the graphical password in the sign up time, so we have to upload this image. And now I need to click on login. We can see that service provider has logged in successfully. Now we need to click on access shared data link to get list of shared files. So I'm clicking on access shared data link. Here we can see subscriber has given permission to access only one file. So blockchain is showing that file only for the service provider to access. At any time, service provider can click on click here link to download the data. Here we can see subscriber name, data description, sharing type, file name, upload date and time, and blockchain identity address. So if we click on click here link in the column of download and view your data column, the service provider can download his data. Now we will log out. In this way, any personal information can be securely stored and that cannot be shared by anybody until we give the access. Conclusion of the project. The project has successfully enhanced data privacy and security for users, providing them with greater control over their data. Blockchain technology plays a vital role in ensuring immutability, distributed storage, and the execution of smart contracts. The use of AES encryption adds an additional layer of security, safeguarding user data from unauthorized access. Integration with interplanetary file system provides decentralized and reliable data storage, further improving data accessibility. Users, both subscribers and service providers, benefit from project's features, allowing for secure data sharing, access control, and accountability. PETchain offers a comprehensive solution for users to maintain control over their data while using online services, mitigating the risks associated with the centralized data storage.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.